we basically started we finished the first several pages of this lecture note, right? So basically we want to talk about the deadweight loss of taxation. And the tool we want to use is this supply-demand curve. And later we will think about how elasticity will affect the size of the deadweight loss. But now we're just focusing on these two curves. So what you can see here is once the government imposes tax, what will happen here is first you will see a wedge between the demand curve and the supply curve. Right? So I know I have used several times the word wedge, and it's fairly intuitive, right? So you can see that this is the wedge. And you can see that because of taxation, because of this wedge, there are several things happening. First, quantity demanded, or the equilibrium quantity, will be lower. Right? Second, prices will change. To be more specific, price paid by buyers will be higher. Right? So basically, you can see that originally, the price was given by this dot. And now, price paid by buyers is higher. And price received by sellers will be lower. And you can see that, again, originally, the price was given by this red dot. And now, price received by sellers is given by this. Right? So that's basically what we could say about equilibrium prices and the equilibrium quantity. But now our focus is about efficiency, right? When you're talking about efficiency, you will use the concepts of consumer surplus and producer surplus. So let's analyze how the welfare, how the efficiency will change because of this tax. What we're gonna do is we will first find out what is the total welfare if there is no tax. And then we will think about what kind of total welfare we can get with tax. Then we will compare these two cases and we will think about how total welfare change, right? How total welfare changes because of the tax. Okay, so this is actually fairly simple. Okay, let me see how would I want to proceed. Okay, let me use the space here. Okay, so let's think about consumer surplus. Right? Now, first let's consider no tax. And next, we could consider with tax. And then we could consider difference. Right? Of course, we also want to consider producer's surplus. And we also want to consider tax revenue. Right? And we also want to think about total surplus. Okay, great. Let's see what kind of results we can get here. So first, if there is no tax, you can see that consumer surplus is given by A. Okay, maybe let me use a different color. It's given by A plus B plus C, right? Just look at this graph. You can see that the consumer surplus is given by the area between the supply curve and the price. Right? Price is given by P1. So the area between P1 and the demand curve is A plus B plus C. Now, if there's no tax, producer surplus is given by DEF. So it's given by DEF. again, we talk about this. Producer surplus is given by the area between the price and supply curve, right? So you can see that price is P1, so the area between P1 and the supply curve is DEF. Now, what is tax revenue? Well, now we're considering the case without tax. So the tax revenue is just 0. Now, what is the total surplus? Well, total surplus is basically the sum of consumer surplus, producer surplus, and tax revenue. So here, total surplus is A plus B plus C plus D plus E plus F. Now, let's consider the more interesting case. That is the case with tax. Now you can see that after imposing tax, the quantity demanded would be given by Q2. And in this case, price paid by buyers is given by PB, this guy here. And we know that the area between the demand curve and the price gives you the consumer surplus. So consumer surplus here is just A. And if you look at this graph, you can see that after imposing tax, price received by sellers becomes PS. So in this case, producer surplus is just given by F. Of course, now we will have tax revenue. Tax revenue equals the size of tax times quantity, right? So basically, tax revenue is given by B plus D. So now you can see that the total surplus is given by A plus B plus D plus F. Now let's look at the difference, right? What kind of difference we're having here? You can see that after imposing tax, consumer surplus becomes smaller, and the difference is given by minus B minus C, right? It's essentially the decrease. B and C is the size of decrease in consumer surplus. And graphically, you can see that after imposing tax, this piece of consumer surplus will just disappear, right? And now, what is the decrease in the producer surplus? Well, it's minus D minus E. So in this case, you can see that the loss in producer surplus is given by this area. And what is the difference in tax revenue? Well, tax revenue obviously would increase because now we have tax. So it's B plus D, right? Now, what is the total difference? Well, to look at the total difference, you could just sum up these three pieces of differences, right? This gives you minus C minus E, right? Or to calculate the total difference, you can actually compare these two guys, right? You could just compare these two different total surplus under the scenario of no tax and under the scenario of with tax. And then you will see that the difference is minus C minus E. That is, because of the tax, there is a loss. And this loss is called deadweight loss. And this deadweight loss is measured by the area of C and E. And you can also see this from this picture here, right? We have learned because of the tax, consumer surplus will reduce by B and C, and producer surplus will reduce by D and E. And also, tax revenue will increase, right? Will increase by B and D. So this part is tax revenue. Essentially, you could see that the reduction in consumer surplus and producer's surplus can be partially offset by the increase in the tax revenue. But sadly, it cannot, the increase in tax revenue cannot fully offset the decrease in producer surplus and consumer surplus. So that's why you will see that the area of CE, this triangle shaded in pink, would actually measure the deadweight loss, right? So basically, to summarize, the key here is you should see how could you find out the deadweight loss if there is a tax. The deadweight loss is just given by this triangle, and you can see that the three sides of this triangle are the size of the tax, demand curve, and supply curve. So basically, the deadweight loss of a tax can be measured by a triangle which is formed by the tax, right? The tax and demand curve and supply curve. Okay, what's the economic intuition behind this result? So why do we get this deadweight loss? Well, okay, I think this picture is pretty complicated. So let me draw a simpler one for you. Okay. Oops. Now let's say there's a tax. We'll just put tax here. And you can see that if there's a tax, then the quantity will reduce, right? The quantity will reduce from Q1 to Q2. Right? And what you can see here is previously, right, the Q1 drops or reduces to Q2. You can see that previously, when the quantity was at Q1, then you can see these buyers, right, these guys, and these sellers, they will actually trade with each other. That is, buyers on this section, right? Buyers on this section will buy product from these sellers. Right? Basically, it implies that here, for these buyers and sellers, willingness to pay is larger than the cost of production. So there is some net positive gain from trading with each other, right? You can pick up any quantity. For example, if you pick a quantity here, let's say this guy's willingness to pay is given by 8. Then the seller's willingness to pay has to be lower than 8, right? Let's say it's 6. Now you can see that obviously there is a value of 2 total surplus from this transaction, right? So that's why tax will cause deadweight loss. It's just because after imposing tax, the quantity drops from Q1 to Q2. So this $2 total surplus we just talked about cannot be realized, right? So that's why. Oh, that's weird. Why? Oh, gosh. Okay, good. So you can see that the textbook also gives you a more complete, which talks about the same thing. And basically you can see that the gist of this picture is it tries to say that if you pick a quantity between Q1 and Q2, the value of buyers is larger than the cost of sellers. So there is a gain from trade. However, because of the tax, the gain is prevented from realized, right, by the tax. Then there is this loss, this deadweight loss. Okay, let's finish this very simple exercise. So we're looking at the market for plane tickets. First, compute consumer surplus, producer surplus, and total surplus without a tax. Oh, this is easy, right? So if there is no tax, then price would be given by $200. Quantity would be given by $100. So here, quantity would be given by 100 units, not dollars. So consumer surplus is given by 1/2 height times, so what is height here? The height of the triangle is 200, right? Times base. The base is 100. So this gives us 10,000. And producer's surplus is 1/2. Again, the height is the same. Base is the same. So you can see that producer's surplus is also $10,000. In the case of no tax, total surplus equals consumer surplus plus producer surplus. So total surplus equals 20,000. Next, if $100 tax per ticket, compute consumer surplus, producer surplus, tax revenue, total surplus, and deadweight loss. Now, let's first find out what happens to quantity and price if there is a $100 tax. So where can you get this $100 tax? We need to find a wedge, and the length of the wedge is equal to 100, right? And you can see that it should be here, right? And you can see that under this tax, the price paid by the buyer would become $250, and price received by the seller would become $150. And quantity would decrease from 175. So now let's calculate consumer surplus. So consumer surplus is given by 1/2, the height, which is 400 minus 250. So it's 150. And the width is given by the quantity, which is 75. So it's, okay, let me check what's the answer here. So it's 5625. And producer surplus is 1/2 times, again, 150 times 75. So it's the same 5625. Now tax revenue is given by the size of the tax times quantity. So it's 100 times 75, which is 7,500. Now total surplus equals the sum of these three values. So it's 5625 plus 5625 plus 7500, which is given by 18750. Now, what is the deadweight loss? Deadweight loss is essentially the difference between the total surplus without tax and the total surplus with tax. Right? So basically, deadweight loss equals 20,000 minus 18750, which is I guess it's 1250. Right? Obviously, there's a different way to calculate deadweight loss, because we have said if you're thinking about calculating deadweight loss, then it's just this little triangle here, right? So to calculate the area of this little triangle, we need to find out this little triangle's base and height. So the base is given by this, which is 100. And its height is given by this, which is 25. So a second way to calculate deadweight loss is to directly compute the area of this triangle, which is 1/2 times 100 times 25. So this again gives you the same answer, which is $1,250. Okay, now let's talk about the last topic of this chapter, which is how the size of deadweight loss is determined and how the tax revenue will change when you change the size of the tax. So, what's the answer to the question that what determines the size of the deadweight loss, right? So the answer is elasticities, right? So let's just see these examples and it will clearly tell you how this results will hold. So first, let's compare graph A and graph B. Under these two graphs, you can see that you have the same demand, right? The demand curves in these two graphs are the same. The only difference is the supply curve. And on the right-hand side in graph A, the supply curve is quite vertical, right? So we have steep supply curve. Here we have flat supply curve. And we have learned if a supply curve is steep, then it's generally inelastic. And if a supply curve is flat, then this is more elastic. So now let's compare the deadweight loss under these two different kinds of supply curves. So basically you can see that when supply is relatively elastic, the deadweight loss is actually larger, right? So you're comparing this guy with this guy. And obviously the deadweight loss in graph B is larger. And in graph B, we have a more elastic supply, right? Okay, you will have the same case when you're thinking about the elasticity of demand. So let's compare graph C and graph D. Here we're having the same supply curve. And the only difference is the elasticities of the two demand curves in graph C and graph D. In graph C, again, we have steep and relatively inelastic demand. And in graph D, we have elastic demand. And now we compare the deadweight losses under these two scenarios. So you can see that the deadweight loss in graph D is larger, and graph D has more elastic demand. So the result here is if demand is more elastic, then the deadweight loss from a tax is larger. So to summarize, if the elasticities of supply and demand are larger, then the deadweight loss of a tax will be larger, right? So that's the conclusion we have obtained. So what's the intuition behind this result? Well, think about the case when we talk about so if you look at this graph, you would see that the reason we are having a deadweight loss is because there is a smaller quantity from tax, right? Basically, after seeing a tax, consumers and sellers will change their behavior, right? In the end, the market quantity will be smaller. Here you can see that it reduces from Q1 to Q2. So reduced market quantity is the fundamental reason why we'll get a deadweight loss. And you can imagine that if the decrease in the market quantity from a tax is larger, then the deadweight loss will be larger. If either a demand curve or a supply curve is more elastic, this implies that either buyers or sellers, they're more sensitive to price changes caused by the tax. This also implies that they will actually change more in the quantity, right? If you're a buyer, if you're sensitive to the price increase because of the tax, then the reduction of your consumption will be larger if the demand elasticity is large. If you're a seller, after seeing the tax, and if your supply curve has large elasticity, then the reduction in quantity will also be larger, right? So in the end, larger elasticities imply larger reduction in quantity from the tax, which implies larger deadweight loss. Okay, great. Now let's look at this little question here. Will a tax on wine or a tax on milk have a larger deadweight loss? We just talked about this, right? The size of the deadweight loss depends on the elasticity. Now, let's first look at wine. For wine, should you expect a larger elasticity or a smaller elasticity? Right? Or let's say, if we compare wine with milk, which one should have smaller elasticity? You might think it should be milk, right? Think about this. Milk is really like a necessity, right? So basically, you will consume your milk like every day. And even the price increases, you will still have to drink milk. So basically, you can see here, we could consider milk has smaller elasticity compared with wine. Now, this implies if there is a tax, then the deadweight loss on wine should be larger because wine has larger elasticity in its demand curve. Okay. Now let's look at a very interesting result. That is how deadweight loss and tax revenue will change if we change the tax. So to understand this, let's just look at this very simple picture. We are comparing three different kinds of taxes: a small tax, a medium tax, and a large tax. So let's just start from graph A with a small tax. So here you can see that if the tax is small, you can see that the deadweight loss is also small. Now let's move to the right. Let's look at graph B. With a slightly larger tax, the deadweight loss is larger. And we continue to move to the right. Now we're looking at graph C. Here, tax is even larger. And deadweight loss is also even larger. Right? What's this result here? Well, it basically says as you increase the size of the tax, deadweight loss should be larger. Right? This is easy to understand because we have talked about this. That is, why do you have deadweight loss? Well, because there is a decrease in the quantity. And you can see that as you increase the size of the tax, the decrease in the quantity also increases. This implies deadweight loss also increases. Now let's look at how tax revenue will change. A naive thinking would be like this. Well, if you increase tax, then tax revenue should always increase. But this is incorrect. If you look at graph A, you can see that we have a small tax revenue because the size of the tax is small. After we move to graph B, you can see that with the medium tax tax revenue becomes larger. Now, let's continue to increase the tax. You can see that the tax revenue actually decreases. So what's the result here? The result is when your tax was small, tax revenue will increase with your tax. But if your tax is already high, continuing increasing tax will actually reduce the tax revenue. How do you explain this? It's actually very easy to understand. So what is tax revenue? Tax revenue equals the size of the tax times quantity, right? Now, you can see this. If tax is very small, right? If T is small, then tax revenue will be quite small. And in this case, as you increase the tax, you will get higher tax revenue. But if this T is very large, now Q will become very small, right? The quantity will be very small. And in this case, if quantity is already very small, continuing increasing tax will just reduce tax revenue. Now, to summarize our finding, we could use these two pictures to nicely summarize what we have found, right? First, graph D. We have deadweight loss on the vertical axis. And we have tax size on the horizontal axis. So you can see that it's just a monotonic increasing relationship, right? Deadweight loss increases as tax increases. And if we look at the right-hand side, so we have tax revenue on the vertical axis and tax size on the horizontal axis. So you can see that there is sort of this cutoff point, right? The cutoff tax rate. And below this, so let's call this cutoff tax rate. Below this cutoff rate, your tax revenue increases as you increase the tax size. And beyond this cutoff rate, tax revenue actually decreases as you increase the size of the tax. Okay, now let's look at the last little question here. If the government doubles the tax on gas, can you be sure that revenue from the gas tax will rise? What's the answer here? Well, you cannot be sure, right? Because we know that as you increase tax, the tax revenue could increase or decrease. Can you be sure that the deadweight loss from the gas tax will rise? Well, you can be sure, right? Because we have learned deadweight loss always increases with tax. So basically, to solve this so-called quick quiz, you just need to look at these two pictures, right? Then you will get your correct answer. Okay, great. Now let's move to the true-false problems. First, normally both buyers and sellers are worse off when a good is taxed. Well, this is actually right? Okay, you could draw this picture out. Demand, supply, Q, and P. And if there was no tax, right, you can see that we could easily find out what is the consumer surplus and what is the producer's surplus. Well, let's say if there is a tax. Now you can see that buyers will have to pay higher price, sellers will have to receive lower price. So you can see that the reduction in consumer surplus is given by this yellow area, right? And the reduction of the producer surplus is given by this green shaded area. Okay. Second, the tax revenue collected by the government equals the reduced welfare of buyers and sellers caused by the tax. Well, I have discussed this in the lecture note. Basically, this is not correct. The correct statement is the tax revenue collected by the government is smaller than the reduced welfare of buyers and sellers. That's why we are having deadweight loss, right? So let me go back to the lecture note and show you the differences here. Oops. So in this graph, what is the total reduced welfare from buyers and sellers? So it's given by this, oops. It is given by this green shaded area, right? Now, what is the tax revenue raised by the government? It's this blue area, right? So clearly you can see that the total loss from consumer and producer welfare is larger compared with tax revenue. That's why in the end you will have this triangle as the deadweight loss, right? Okay, clearly this is not correct. Third, a tax raises the price received by sellers and lowers the price paid by buyers. Oh, this one is actually pretty easy, right? This is, this one is not right. Basically, a tax raises the price paid by buyers and it reduces the price received by sellers, right? You can quickly see this. So if there's a tax, this is buyer's price, this is seller's price, and this is the original price. The larger the deadweight loss from taxation, the larger the cost of any government program. I would say this statement here is not super rigorous. However, if you consider the deadweight loss as the only measure of the cost of a government program, then you could say this is correct. Fifth, taxes cause deadweight losses because they prevent buyers and sellers from realizing some of the gains from the trade. Well, we talked about this. This is correct, right? So basically you can see that for these guys, if they can trade with each other, they will have some gains because buyers' willingness to pay is larger than sellers' cost of production. However, because of tax, they cannot trade. They will leave the market. So that will result in deadweight loss. Sixth, if a tax did not induce buyers or sellers to change their behavior, it would not cause a deadweight loss. This sounds ambiguous, but if you think about it, it's actually correct, right? Because why do we have deadweight loss? It's because there is a reduced quantity. But why we are seeing this reduced quantity? Well, because buyers and sellers have changed their behavior. Because buyers will buy less if they see a higher price because of the tax, right? So if we can assume if imposing a tax does not change consumers and sellers' behavior, then clearly the quantity will stay the same. Will stay at the original equilibrium quantity. So there would be no deadweight loss. Okay, seventh, the demand for bread is less elastic than the demand for donuts. So a tax on bread will create a larger deadweight loss than the tax on donuts. This is not right? Because we know that deadweight loss is larger for more elastic demand. So here, demand for bread is actually less elastic. So the correct statement is a tax on bread will create a smaller deadweight loss than the same tax on donuts. 8. A tax on insulin is likely to cause a tremendous deadweight loss to society. This one is not correct because insulin is a necessity if you have diabetes. So basically this implies that there will be very small elasticities. And we know that if elasticity is small, then deadweight loss will also be small. So this one is incorrect. 8. 9. Because the supply of land is perfect elastic, the deadweight loss of a tax on land is enormous. Well, it is not correct. The reason is because the supply of land is not perfectly elastic. It's actually perfectly inelastic. Right? What is the case of perfectly elastic? If you're thinking about a supply curve, we know that a curve, if a curve has larger elasticity, then it is actually flatter, right? So if it's perfectly elastic, then the supply curve should be horizontal. So this is the case of perfectly elastic. So it is essentially very flat. Right? So it's very flat. It's the extreme case of being flat. However, we're talking about land supply here. A more often or more widely used supply curve for land is you actually draw a vertical curve, right? The reason is generally you can assume the quantity supplied for land is always fixed, no matter what is the price, right? So here, this is not a case of perfect elasticity. It's perfectly inelastic, right? So in this case, it's perfectly inelastic. Oops. Okay, great. Now we could proceed to talk about international trade. So we will cover both chapter 3 and chapter 9 to discuss international trade. Chapter 3 is like the foundational chapter, which talks about comparative advantage. And I would say this is a quite important concept in economics. If you're economic major and if you have taken economic courses, but you don't understand comparative advantage, then I would say that, it would be a pity. So I hope you could understand this very important concept. So we will start with this chapter with a cute parable, right? A nice sort of kind of story here, right? So it's a parable for the modern economy. So we are thinking about there is a simple economy in a small village. So we basically have two products, meat and potatoes. And it's a simple economy, so we would only consider two goods and we would only consider two people. And one is a cattle rancher and another one is potato farmer. And each of these two people would like to eat both meat and potatoes. And both the cattle rancher and the potato farmers, they can raise cattle and grow potatoes. You can guess that, well, the first guy is called cattle rancher because he is better at raising cattle. The second guy is called potato farmer because he's better at growing potatoes. However, they can do both. So now let's look at the production possibilities frontier. So here you can see that we will have a table, right, which tells us the productivities of the farmer and the rancher. Right? So let's first look at the table on the left-hand side. It tells you minutes you need to produce 1 kilogram of meat or potatoes. So for the farmer, he needs 60 minutes per kilograms of meat and 50 minutes per kilograms of potatoes. For the rancher, 20 minutes per kilograms of meat and 10 minutes for 1 kilogram of potatoes. Now you can look at the productivity difference here, right? Clearly you can see that the farmer is actually this is actually interesting. In this case, you can see that the rancher is actually better in both producing meat and both producing potatoes, right? Because the rancher only needs 20 minutes for 1 kilogram of meat, but the farmer needs 60 minutes. And the rancher only needs 10 minutes per kilogram of potatoes, but the farmer needs 15 minutes, right? Okay, in the future you will see that this is called absolute advantage. But now this is basically are just numbers made up by the textbook. So let's just accept these numbers. Okay. Next, let's see how many kilograms of meat and potatoes can be produced in 8 hours. Right? Well, this is very easy calculation. Right? So basically you have 8 hours of time. And if you need 1 hour to produce 1 kilogram of meat, then for 8 hours you can produce 8 kilograms of meat. Right? For potatoes, 50 minutes. So for 8 hours, the farmer can produce 32 kilograms. And for the rancher, it can produce 24 kilograms because for per kilogram of meat, the rancher needs 1/3 hour, right? And for the rancher, for per kilogram of potatoes, he needs 1/6 hour, right? So this implies for 8 hours, it can produce 48 kilograms. So why do we want to calculate these numbers? Well, because we want to find out, or we want to draw out the production possibilities frontier. So let's see the farmer's production possibilities frontier. So we know that if the farmer puts all his time into producing potatoes, he would produce 32 kilograms. So we get this number here. And if the farmer puts all his time into producing meat, he could produce 8 kilograms. So we will get this point. And for simplicity, let's assume the frontier is just a straight line. So in this case, we will have this straight line frontier, right? So that's basically farmers' production possibilities frontier. Similarly, we could talk about the rancher's production possibilities frontier. And we will have 48 kilograms if the rancher puts all his time into producing potatoes, and 24 kilograms if the rancher puts all his time into producing meat. So here you can see that we will have a straight line like this. Again, we assume the frontier is a straight line. So after drawing out the two frontiers, let's assume how the rancher and how the farmer will produce meat and potatoes. For simplicity, let's assume both people, both the farmer and the rancher, would divide their time equally in producing meat and potatoes. Right? Basically, you can see that we are assuming that the farmer will spend 4 hours in producing meat and the other 4 hours in producing potatoes. So the actual production were given by these two middle points, right? It will given by point A, which is just in the middle of this line, and B will also be in the middle of this straight line. So if we assume these two people will equally divide their time in production, then we would see that the farmer will produce 4 kilograms of meat and 16 kilograms of potatoes, and the rancher will produce 12 kilograms of meat and 24 kilograms of potatoes. Now, let's assume the farmer and the rancher, they're isolated with each other. So they will not trade with each other. They will just eat what they have produced, right? They will just consume what they have produced, which means if there is no trade, the farmer will produce 4 kilograms of meat and he will also consume 4 kilograms of meat, and he will also consume 16 kilograms of potato, right? Similarly, for the rancher, he will consume 12 kilograms of meat and 24 kilograms of potatoes. Okay. Now, let's say after several years of living in isolations, a economist like you, right, comes to the village, and this economist offers some suggestions. So what are the suggestions this economist wants to offer? This economist will offer two pieces of suggestions. The first is specialization. The second is trade with each other. So the economist says, okay, I want you two guys to specialize what you're doing best. So basically, the farmer would devote all her time to growing potatoes, and the rancher will spend 6 hours a day raising cattle and 2 hours growing potatoes. So basically, farmer will focus on will only focus on potatoes, and rancher will mainly focuses on raising cattle. And after the specialization, the economist offers the suggestion of trading with each other. That is, the farmer will give rancher 15 kilograms of potatoes in exchange for 5 kilograms of meat from the rancher. Now let's see, will the rancher and the farmer be happier with this kind of suggestion? Well, that is, will this suggestion be followed by the farmer and rancher? Right? So let's see the numbers here. The focus here would be the table on this right hand side. That is table C here. Now, let's look at the first row, right? The first row is the case of production and consumption without trade. We have got these numbers 4, 16, 12, and 24 from the previous slides, right? We got these 4 numbers from this slide. Now, we think about the case with specialization and with trade, right? So we're thinking about this case here. Now let's first think about production, right? Remember what's the suggestion offered by the economy. The economy suggests the farmer devotes all her time to growing potatoes, right? So in this case, you can see that if the farmer devotes all her time, then she would have 8 hours to grow potatoes. So she would actually grow 30 kilograms of potatoes. So that's why the farmer will produce 0 kg of meat and 32 kg of potatoes. Now let's look at the rancher. So according to the suggestion of the economist, the rancher would spend 6 hours raising cattle and 2 hours growing potatoes. And if you look at the productivity of the rancher, right? Now clearly the rancher would spend 1/3 hours to produce 1 kg of meat and 1/6 hour to produce 1 kg of potatoes. Now if the rancher has 6 hours for cattle, then she would actually produce 18 kilograms of meat. And if she has 6 hours growing potatoes, then 2 divided by 1/6, we will have 12 kgs of potatoes, right? Now let's see how the trade will happen. The trade happens like this. Farmer will give rancher 15 kgs of potatoes, right? So 15 kg will be deducted from the farmer's production, and it will go to the pocket of the rancher, right? And then the rancher, in exchange for 15 kgs of potato, the rancher will have to give 5 kgs of meat. So the 5 kilograms of meat will go out the pocket of the rancher and go into the pocket of the farmer, right? So in the end, we can see that by specialization and trade, the farmer will get 5 kgs of meat and 17 kilograms of potatoes, right? It's basically 32 minus 15. And the farmer will have 13 kilograms of meat and 27 kilograms of potatoes. Now, what's our focus here? Our focus is we want to compare this line with this line. And you can see that this is a fairly interesting result, right? If you compare the case with trade and without trade, you can see that there is gain from trade. That is, the farmer will have 1 more kilograms of meat, 1 more kilograms of potatoes. The rancher will have 1 more kilograms of meat and 3 more kilograms of potatoes. So if we go back to our question, that is whether the farmer and the rancher will be happy to accept the economist's suggestion, then you can see that the answer here is yes. They will happily accept the suggestion from the economist. and they will actually follow these suggestions. They will start specialization and then they will trade with each other because trade makes both of them better, right? You could also see this from this picture here. So previously without trade, when there was no trade, the consumption of the farmer is at point A with 4 meat and 16 potatoes. And after trade, interestingly, you can see that the consumption of the farmer actually goes outside of the farmer's production possibility curve, right? The farmer will consume 5 meat and 16 potatoes. And the same thing happens to the rancher. When there was no trade, the rancher will produce at point B and consume at point B with 12 meat and 24 potatoes. And after following the suggestion of the economist, you can see that the rancher will move the production from point B to this red point, right? And then through trade, the rancher's consumption will also improve. The rancher will have 16 units of meat and 27 units of potatoes at consumption point B star. And more importantly, you can see that the combination B star is actually outside of the rancher's possibility frontier, right? So this basically tells you that specialization and trade, they make both of these two people better. Now what's the intuition here? The intuition is actually fairly simple. Basically, through specialization, then each of the farmer and the rancher, they can specialize doing what they do best. And farmers will spend more time growing potatoes and less time raising cattle. And rancher will spend more time raising cattle and less time growing potatoes. So because of the result of the specialization and the trade, then each of these two people, they would actually consume more meat and more potatoes without working more hours. At this stage, it might seem a little bit of weird because if you go back to the table, you can see that rancher is actually better at both raising cattle and growing potatoes. It seems that we should let rancher do both. Well, this is not right. The reason is because specialization is determined by comparative advantage. It's not determined by absolute advantage. I know I have not talked about these two kinds of concepts here. However, I just want to give you this preview that what we will talk about in the next class. That is, how we should determine specialization, right? Okay, let's see this example here. Okay, this is awkward timing. This is this is a long example. So let me stop here and we will talk about this long example on Thursday's class.